The analysis of variance test, or Anova, is when you're comparing the means of 3 or more groups to find out if they're all the same or if at least one is different. The requirements are that you have simple random samples, normal population, and then either the populations have the same variance, which you probably won't know if you only have samples, or you could calculate the sample variance, or as long as your sample sizes are large and about the same size for each sample, you would be okay as if your variances aren't close together. And then the samples need to be independent. There's no pairs or relationships between the groups. For the sake of our class, we're not going to learn the equations for Anova. There's multiple equations that you would need to use to solve for f, which is our test statistic. We're just going to learn how to use a calculator, and then later on we'll learn how to use Excel to do an Anova test. So let's take a look at the distribution for the test statistic. Our test statistic is f. So we've used z, we've used t, we've used chi-squared. Now this one is another new one called f. It's not symmetric, so where z and t were normal bell-shaped curves, the f statistic distribution looks something more like this. And it's always right-tailed, so whatever your value of f is, the p-value is always the area to the right of that. And if you're using the table, there's an f table to look up p-values, you would need 2 different degrees of freedom. You have k minus 1, where k is the number of groups, and n minus k, where n is your total number of observations, and k again is your number of groups. Okay. And see, before we get too far, let's back up and take a look at what this test does. What you're doing is finding out if your groups are different or not, or if at least one of the groups is different. So if you had a distribution like this, where maybe this is your distribution of group 1, and then you had another group 2 that had this distribution, and then group 3 maybe looks something like this. You can see there's a lot of overlap between these groups. 2 and 3 especially are fairly similar to each other, but 1 has all this overlap with both 2 and 3. So if you had a case like this, you would probably end up with a p-value that's not significant. So these groups have overlap, probably no significant difference. And then if you had groups where this is group 1 distribution, and then group 2, and group 3, you can see there's a little bit of overlap between the groups, but there's no overlap between group 1 and group 3, so there's a lot less overlap here. And you'd probably get a significant difference. Okay. So this is what the Anova test will do. It will kind of look at the variation within a group and the variation between groups, and kind of look at how much overlap there is with the groups to determine if one or more of them are different from the rest. So the example for an Anova, we're going to be looking at different regions of the United States and salaries of teachers in each of those regions. The sample data has already been collected, and you'll see that we have sample data for each of the 5 regions of the United States. So let's check our requirements. We need a simple random sample, And it says random sample in the problem, so we'll assume it's a simple random sample. We need normal distributions. It doesn't say in the problem, but usually salaries follow a fairly normal distribution, especially within just one job type. So we'll say probably on that. Then we either need the same variance, so equal variances, and either the sample size is large and similar n for each group. So of these two, we don't really have large sample sizes. There's only 6 or 7 in each group, but they are similar in size, and we could calculate the mean and standard deviation of each group, and this variance, remember, is the sample size squared. Okay. And if we did that, you'd see that they're fairly similar to each other. So we'll go ahead on that one, and then they have to be independent groups. So the teachers in one region of the United States shouldn't be paired with the teachers in any other group, and that is also true. Okay. Our hypotheses for an Anova, the null hypothesis is always that all the groups are equal. So we can say all regions of United States have same teacher salaries, and the alternative hypothesis is always that at least one group is different. So at least one group has a different teacher's salary. Alright, so again, we're not going to be learning any of the equations for an Anova. We're just going to see how our calculator will do this. Okay. And to save time, you can see that all the values are already in my calculator. So each region, Northeast, Southeast, Midwest, Plains, and West, are list 1, list 2, list 3. And if we scroll over, you'll see I have list 4 and list 5. So you need a separate list for each group. And get those all into your calculator. And then to do an Anova, go to Stat menu, Tests, and Anova's on the bottom, so just push up arrow once and there's Anova right there. And what you have to tell your calculator is which lists your groups are in. So we have 5 lists. So there's list 1, comma, list 2, and I'm just doing second a number to get your list. So list 3, list 4, and list 5. Okay, so we had 5 groups, so we used 5 lists. Hit enter, and there's our results. So we have F equals 2.34. The p-value is 0.0794. All these other numbers are results of all the equations that go into calculating F. So you can see that it's quite a bit of work that goes into calculating F, and we're not, again, learning any of those equations. So what you're interested in out of your output is the F and the p-value that's right at the top of the results. So F is 2.34, the p-value was 0.0794. Okay. Again, all those other numbers, you can just ignore them, and let's make a conclusion. So p-value of 0.0794, alpha is 0.05. P-value is bigger than alpha, so we fail to reject the null hypothesis. And in the context of the problem, fail to reject the null hypothesis means all the regions of the U.S. have the same teacher salaries. And that's it. That's all you have to do an ANOVA problem. Again, we're not learning any of the equations, so as long as you know how to enter the data in your lists and tell your calculator which lists you're using, and then write down your F and P value, make your conclusion, and that's the end.